Hello students, let us continue with exercise 5.1 of chapter 5 of your textbooks, Introduction to Euclid's Geometry. In the previous class we completed the first two questions, so we'll proceed quickly with the third one. Let's read it out. Consider two postulates given below. So we have two postulates and based on these two postulates we have certain questions to answer. So the first one is, given any two distinct points A and B, there exists a third point C which lies between A and B. So this is the first postulate, and the second one is, there exists at least 3 points that are not on the same line. So let's read out the question. Do these two postulates contain any undefined terms? Let's check. The first one, given any two distinct points. So I have points. There exists a third point. So again point which lies between A and B. And the second one, there exists at least 3 points. I have already marked points that are not on the same line. So here are two undefined terms. So I'm going to write 3(1). Yes, the two undefined terms are point and line. Let's read out the second question. Are these postulates consistent? So do you think that these two postulates are consistent? Let us check. So the first one, given any two distinct points A and B. So I have two distinct points A and B. There exists a third point C which lies between A and B. So if I join these 2 points, there is a third point C which lies between A and B. And the second one, there exists at least 3 points that are not on the same line. So if I take my 3 points as A, B and C, they are not supposed to be on the same line. Let's say A and B are on the same line, A and B, and the third point cannot be on the same line, so C. Let's read out a question again. Are these postulates consistent? Yes, these postulates are consistent because they are applicable for two different situations. The first situation where C lies between A and B, and the second situation where there is a third point C which does not lie between A and B. Therefore, you can say that these two postulates are consistent. Yes, these two postulates are consistent because they are for two different situations. And we'll just write the situations. Situation 1, where point C lies between A and B, and the second situation where point C does not lie on the line drawn by joining points A and B. Right? And the second question, do they follow Euclid's postulate? Explain. So if you go through your list of postulates that we have learned in our previous classes, you will notice that none of these postulates, they belong to Euclid's postulates. However, they related to axiom 5.1. So what is axiom 5.1? Given any two distinct points, there is a unique line that passes through them. So we'll write this down. No, they do not follow Euclid's postulate, but are in lines with, but can be related to Axiom 5.1, given any two distinct points a unique line passes through these points. So we have done question number 3. We'll quickly read question number 4. If a point C lies between points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. Explain by drawing the figure. So what we'll do is read out the question and draw the figure first. So according to this question, we have 2 points A and B. And we'll connect them using a line. Now there lies a point C in between A and B such that AC is equal to BC. So AC here is equal to BC. So I'm just marking dash for AC and CB just to show that they both are equal. We have to prove that AC is equal to half of AB. So I'll write my question given AC is equal to BC to prove that AC is equal to half of BC. We'll continue with the proof on that side of the board. I'll say proof. AC is equal to BC. This is given, right? So AC is equal to BC, which is given. Now what I'm going to do is I'm going to add AC on both the sides. So if I'm adding the same term on both the sides, the equation will still be the same. It will be AC plus AC is equal to BC plus AC. So adding AC on both sides, we get AC plus AC is equal to BC plus AC. So AC plus AC is nothing but 2AC. It's like one apple plus another apple gives me 2 apples. Now let's see what is BC plus AC. I can write BC plus AC as CB plus AC, which can also be written as AC plus CB. Correct? See, I have just written, we have BC plus AC. What I did is, this is AC. This is BC plus AC that we've got. Instead of writing BC, I have written CB. BC is the same as CB. So I have just written BC as CB and AC I have left it as it is. Then I have swapped these, AC and CB. Now if you see AC plus CB, this is AC and this is CB. If you are adding them up, what are we getting? We are getting the line segment AB. So this can be written as AB. So I have 2AC is equal to AB. Now since 2 is getting multiplied with AC, it will come on the right hand side and divide it. So AC is equal to half of AB, which is what we require. AC is equal to half AB. I'm sorry, I have written this incorrectly. AC is equal to half AB. Here, AC is equal to half AB, which is what we need. So I'll say hence proved. Right? Now let's move on to the 5th question. In question 4, so referring to question 4, C is called the midpoint of the line segment AB. So C is the midpoint of this line segment AB. Prove that every line segment has one and only one midpoint. So we need to prove that for any line segment AB, there exists a unique midpoint. So what we'll do is, initially we will assume that there is no single midpoint. So what I'm going to do is just redefine my line over here, or rather I'll just let this be as it is. Let's redo it there. So fifth one, I have A, B, C, and I'll say there exists another midpoint. So what I'll do is I'll say there exists two midpoints, let's say C and D. So we need to prove that C and D are the same points. Proving that C and D are the same point, that means there exists only one single midpoint for any given line segment. So let's prove this. I'll say let there be two midpoints of line segment AB. Let these 2 points be C and D. Correct? That means C and D are two midpoints. So now, by using this definition, what do I get? AC is equal to half AB and AD is equal to half AD. Correct? So what do I get? I get AC is equal to AD. Why? Using our axiom which states equals that are equal to the same thing are equal. So therefore, AC minus AD is 0. Correct? I got AD on my left hand side, so AC minus AD is equal to 0. So what is AC minus AD? It's actually AD minus AC in this case. So instead I'll say 0 is equal to AD minus AC. Why did I take AD minus AC? Because AD here is the larger part and AC is the smaller part. So AD minus AC is 0 because I got AC on my right hand side. So what is AD minus AC? I got CD. CD is equal to 0. CD is equal to 0 implies C and D are the same points. That is, there is no space between them. Therefore, C and D are the same points. That is, C and D coincide. Therefore, a given statement here that every line segment has one and only one midpoint. Therefore, every line segment has one and only one midpoint. Clear? So let's move on to our question number 6. But as you can see, we do not have enough space, so I'm going to erase this section of the board. I hope you've taken a note of this. Let's read out our sixth question. In figure 5.10, so this is figure 5.10. Prove that AB is equal to CD. If AC, okay, in figure 5.10, if AC is equal to BD, that means AC is equal to BD, prove that AB is equal to CD. So let's write a given to prove that and prove. Sixth question. In line segment AD given AC is equal to BD. To prove that AB is equal to CD. So I'll say proof. And I'll write my given as it is. AC is equal to BD. So I have AC is equal to BD. What do they have in common? They have in common BC. And we also need to prove that AB is equal to CD. So what I'm going to do is, on both the left hand side and right hand side, I'm going to subtract BC. If I subtract BC on both the sides, I will be left with AB is equal to CD, which is what we need to prove. So let's do this. Subtracting BC on both sides. What do we get? AC minus BC is equal to BD minus BC. So let's see. AC minus BC will give me only AB. So I write this as AB. And BD minus BC will give me CD. So this is equal to CD. Isn't that what we need to prove? So I'll say hence proved. Clear? Quite a simple question. Now the last one of exercise 5.1. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Note that the question is not about the fifth postulate. So we are talking about the axioms and not the postulates. And so first let us down what is the fifth axiom. The fifth axiom reads that the whole is always greater than a part. So we will first write our question. Seventh, axiom 5. The whole is always greater than a part. Now since we are saying universal truth, it is not important to give any mathematical or geometrical explanation for this. You can just give a real life example. So let's say we'll take our example of a pizza. I think we've done this earlier also. So if I have this pizza and I cut this portion, so what am I left with? I'm left with two parts, right? When I remove this part, I'm left with this part and this part. Now obviously you can see that this part is less than this entire part, and also this part is less than the entire part. Therefore we can just say that it is universal truth. So we need to write down explanations for this. Let's do this. So for solution for 7, actually a solution starts here only. Let's consider a pizza, then cut a small section from this pizza so this is in form of steps. Compare the two pieces with respect to the entire pizza. What is your observation? The two parts or each of the two parts are smaller than the entire pizza, or you can also say that, or the entire pizza and in brackets you will write whole is greater or larger than the two small sections cut from the pizza. So for sections I am going to say part. Therefore, what can I say? Axiom 5 is universal truth. Therefore, axiom 5 is considered as universal truth. So if you notice, the first two questions were pretty lengthy and a little tedious, but as we proceeded further, the remaining questions didn't take much time, as well as they're pretty. So this needs a lot of common sense of understanding, and you just need to look at the figure and try to understand how to deduce your answers. And also you have to be very thorough with your axioms and postulates, because they might just ask you questions based on a certain axiom. They'll give you a certain axiom number or postulate number, and then you will have to write down the definition of it as well as solve your question. So make sure you just have 5 axioms given and 5 postulates and 1 extra axiom 5.1 for proving your another postulate, that was 5.1. So that was postulate number 5. So just make sure you know 11 of these statements very correctly, and then solving these exercises would be very simple. So with this we wind up exercise 5.1. We will continue with the rest of the chapter in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.